right, this is free response number 2 for review day 5. We have an equation of people in a line for an escalator for the first 300 seconds, and then after that, nobody's getting in line for the escalator after that. We're also told that constantly people are getting off the escalator at a rate of 0.7 people per second. And there were 20 people waiting in line initially. All right, so A says how many people entered the line from 0 to 300. So this is the rate that they're entering. So in order to answer that, we'll do that down here, part A. It's just the integral from 0 to 300 of r of t. Okay, if you had that integral on your paper, give yourself a point. And then if you put it onto your calculator, you should have gotten 270 people, and that would give you a second point. Okay, so a pretty easy one to start with. Part B says during the time interval 0 to 300, there are always people in line. How many people are in line at time 300? So a little confusing at the first, but really all they're saying is, okay, now you know how many people were there to start with. There were 20, and you found out how many people entered the line, plus the integral from 0 to 300 of r of t dt. And then the only thing we have to kind of add to this is how many people got out of line. And from 0 to 300, they were getting out at a rate of 0.7. So this is something we've worked on quite a bit. What was there to start with, plus what was added, minus what was taken away, right? And if we work all that out, we should end up with an answer of 80 people. Okay, so how do they give you points here? They give you 1 point for including this in some way, and then 1 point for the answer. So putting it all together got you another point there. Okay. C says for time 300, after 300, what's the first time that there are no people in line? So we just found out that at the end of the 300 seconds, there were 80 people still in line, and now they're not getting on the escalator anymore. The rate says that they're not coming on. They're just leaving at 0.7 people per second. So this really is kind of like an algebra problem. 80 people are in line. They're getting out at 0.7 people per second. How many seconds would it take? Well, we would go 80 people divided by 0.7 people per second. And if we do that, we're going to end up with an answer of 114.286 seconds. Now you got to be careful because that's after the 300, and they're asking about the total time. So we do have to add the 300 that was there before. So unfortunately, if you had that idea but you forgot to add the 300, that would have cost you. It's at time 414.286 seconds, which is a weird time, but that would have gotten you a point for that. Okay, really no calculus involved, just kind of an algebra problem at that point. Now D says, at what point do we have the minimum number of people? So in other words, if you're thinking about this, maybe we can kind of look at the graph of that. And here's the rate coming in, and here was the rate leaving, was 0.7. So when we look at a graph of that, the hump here is the rate that people are coming in. The flat line is the rate they're leaving. So initially, more people are leaving than coming in, right? Up till this point right here. So we'd like to find out what that time is. After that, more people are coming in than leaving until this time here. And then after that, for the rest of the time, it looks like more people are leaving than coming in. So if we have a minimum, it's going to be here or at the end, right? So let's find that time there. Intersect. Let's bring this on over. And these two graphs intersect at time 33.013. Now I want to kind of keep that number. I don't really want to. So actually what I'm going to do is I'm going to go ahead and go X store alpha A so that I have the full length. I don't want to round too early or it might catch me here. So I got to write this out a little bit here. So I'm going to say max or minimums occur when R of t equals 0.7. So what I'm trying to tell the grader is I'm looking for that intersection. When does the rate coming in equal the rate leaving? You could even write, rate in right out. Okay. The reason we want to write that is because that would get you a point for explaining what you're doing. If you just write 33.01, the grader doesn't know where that number is coming from and may not even give you that as an answer. So we would say that our minimum could occur at t equal 33.013 or t equal 300. All right, and they gave a point for this time right here, which kind of again gets you, these two together aren't too bad based on what we've done before. What we have to do is figure out what the amount was at those times. So we'll start with t equal 33.013. We're going to go 20 people in line plus the integral from 0 to that time. Now that we're going to let a equal 33.013 and so on. And so we're going to write letter A on our paper. We don't have to keep writing that time over and over again. R of t, this will be the number of people that came into line at that time, minus from 0 to A, 0.7. Okay, so on our calculator, again, we have A already listed there, so I can just go 20 plus math 9, 0 to A, y1 dt, minus math 9, 0 to A of 0.7. Hit enter, and I get 3.803. So can't have 0.803 of a person, that's gross. We're going to say 4 people were in line at that spot. So at t equal 33.013, there were 4 people in line. Okay. Now, we already know at t equal 300, there were 80 people in line. We found that in part B. All right. So obviously 4 is less than 80, so our minimum number is right there. That's the minimum. They gave you a point for that answer and a point for the justifications. I believe just showing your work and stuff would get you another point in that. All right. So not too bad. A little bit of work involved, and it can be a little tricky to understand what you had to find there, but once you found it, problem wasn't too bad.